Hi everyone, this is lesson 2.4, predicting the products of chemical reactions. Okay, now I'm going to get you to watch, so I want you to pause this video and click on the other link that I gave you for a video to get the examples and general formulas for the reaction types. So I'm not going to spend a ton of time doing this because this is a review from grade 10, so I want you to look through these and find synthesis. So for example, synthesis, this is coming together, right? Maybe I'll put the general formulas on here. So A plus B goes to AB, and you can get your example from the video. Decomposition, this would be AB breaking apart into A plus B. Single displacement, that would be, sometimes they give the cartoon or the picture of a couple dancing and a third party comes along and interrupts them and steals the partner away, right? So single displacement. Oh, you know what? Sorry, these are supposed to go under the here, and no, they aren't. Never mind. Oh my goodness. It's been a long day. Single displacement, I'm just going to write it here so I have a little bit more room. So A plus BC is going to give you, so the A is going to trade places with the B. So B is now by itself, and we end up with AC. So single displacement, one of those things is going to displace the other. And then we have double displacement. Now in a double displacement reaction, both the species here will trade partners, right? So this one, sometimes people get confused as to what's going to hook up with what here. The A is now going to be hooked up with the D, and the B and the C are going to be hooked up here. So we've got AD plus, and now here you have to remember which one gets written first, and it's actually CB because we write the non-metal first. So the C is going to come before the B. Now combustion, this would be some hydrocarbon plus oxygen gas. We need oxygen gas to burn, right? Will give us carbon dioxide plus water. Now these ones are easy to predict the products for because the products are always carbon dioxide and water, and the difficult part will just be balancing those. So anyways, I want you to go ahead and watch the video on this, and then that will give you all of the examples here for you to write in. Okay. Now, we're going to look at predicting the products here. So if given a reaction type, you can predict the product. So you have to know the type of reaction it is though before you do that. So for example, the following reaction is a single displacement reaction. So that means one thing is trading places, right? So I've got magnesium plus barium phosphate, and those are going to trade places. Now the magnesium and the barium are going to trade places. So now barium is by itself. Now a lot of times a common mistake here is this little 3. People will write the little 3 there. Do you write the little 3 there? No, you do not. You don't write it there because that 3 is specific to the bonding ratio, okay? So you don't write the 3, you just write barium by itself. And now we're going to write magnesium phosphate here. So this is also why you have to really practice that naming, right? Because you have to be able to figure out how the bonding ratio all works here. So magnesium has a charge, I'm just going to do this here. Magnesium has a charge of 2 positive. PO4 is 3 minus. So how are these two going to bond? I'm going to need 2 of the phosphate ions and 3 of the magnesiums for it to balance out. So Mg3, PO4, 2, I'm going to put brackets around it, and now that's done. But you always must remember to balance your equation. It's never done in chemistry if you haven't balanced it. So I'm going to look here. I've got 3 bariums on the left-hand side, which means I need a 3 here, and then I need a 3 here for the magnesium, and then I think we're balanced at that point. Yeah. So just always remember that these little subscripts here are specific to bonding ratio, so they don't automatically go with the ion. Okay, we're going to work through a couple examples. I'd like you to pause the video and try these on your own. You truly do learn it better if you can do these things by themselves, right? So I'm going to look at Na2SO4, so sodium sulfate, and lead phosphate. And it's a double displacement reaction. Now, the sodium is going to hook up with the phosphate and the lead and the sulfate. Now, Na has a charge of 1 positive. Phosphate ion, PO4, is 3 minus. That tells me I'm going to need 3 of the sodiums, okay? Plus, and now I want to have the lead with the sulfate ion. Now the lead, how do I know what the charge is on that lead? I have to remember that it's bonded in a 1-to-1 ratio with the PO4, and PO4 is 3 minus. So that tells me that that lead has to be 3 positive. And so the lead is going to be 3 positive. The sulfate ion I know is 2 minus. Remember, SO4 2 minus. So I've got a 2 negative and a 3 plus. So I want to get those both to 6. So it's going to be PB2 and then SO4 3. And now I have to balance this big reaction here. I'm going to need a 3 here, a 2 here, and a 2 here, and I think that will take care of it. Wait, did I mess it up? I feel like I made a mistake. I think I may have typed in something wrong. Hold on. Oh no, I'm right. Sorry. Yeah, it's good. Sorry. So yeah, PO 2 of the phosphate ion, 2 of the phosphate ion. Yeah, 2 leads, 2 leads. Yeah, we're good. 3 sulfates. So this is all balanced now. So again, like that's a good example of how you always have to really double check it, okay? So just be really careful when you're doing these. Next, we have combustion. So this would be some sort of hydrocarbon, so something that contains carbon and hydrogen, and we're adding oxygen to it. Now again, when you get combustion reactions, don't even think about it, just write CO2 plus water. And then the tricky part will just be the balancing. So I'm going to put a 6 here because I've got 6 carbons there. Next, I'm going to look at the hydrogens. I've got 12, so I'm going to put a 6 here. Now I look at oxygens. I've got 6, 7, 8 oxygens over there, and I've got 6, hold on, no, that doesn't work. So I've got here, coming here, I've got 12 oxygens, and I've got 6, so I need 18 oxygens total. Over here, I've got 6 from here, so 18 minus 6 is 12, which means I'm going to need a 6 here. Yeah, and that all works. So I've got 3 6s in a row then as my coefficients. Good. Okay, synthesis for this one. So I've got potassium and chlorine. So these are coming together, so combining. So a lot of people here will write this. Do not write that, okay? You have to look at bonding ratio and apply it, okay? I'm just gonna redo this. So you need, this is going to be K. Now potassium, when it ionizes, makes K plus. Chlorine, when it ionizes, is 1 minus. So these are going to bond in a 1-to-1 ratio, and then you just need to balance it like that. And that's that reaction there. I've predicted the products there. Next, lastly, we're going to look at is decomposition. So again, this is breaking apart. And again, a common mistake here is to do this. So that's what it breaks apart into. Now, what are you forgetting here? Do you know Hofbrinkel? Hopefully your grade 10 teachers told you this. Not all grade 10 teachers do. Hofbrinkel is a way of remembering which of the atoms or which of the elements will never be alone. So these all form diatomic molecules. What that means is, for example, the H, you will never see one single atom of hydrogen floating around the atmosphere. if there is an atom of hydrogen, it will immediately bump into another atom of hydrogen to form H2 gas. So that's our diatomic molecule. So 1, 2, 3, 4, 5, 6, 7. There's 7 of them here. These all do this. So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. So I really, really suggest you remember this Hofbrinkel term. Incidentally, no one ever taught me that. And I was like, man, that would have been helpful as I did my chemistry degree. And it would have been a nice, really easy way to remember that. So bromine, of course, is a Hofbrinkel atom as well, which means it will never be there by itself. So that's one trick you got to kind of watch for when you're doing these. And then, of course, we want to balance this, so I'm going to put a 2 in the front. Now, your assignment today is exercise 5. Work hard on this. Give this a try. We will correct it in class. And this is an important concept. I always put at least a couple of these on people's unit tests, and it tends to be a concept that people struggle a little bit with. So work hard. Give it your best shot here. Okay, thanks everyone.